Max Kuhn and team. Max, please go ahead.
Excellent. Thanks for the invitation and appreciate everybody being here. So I have three things to talk about. This is joint work with Hannah, Emil, and Shushi. I'm going to try to do this as 3 lightning talks. And I don't think anybody's here to gong me, but we'll see what happens. So first thing is censored regression in tidymodels. This is basically survival analysis where we have an event time that may not be complete. Survival models and tidymodels have been around since the beginning. We had parametric models originally, and we've expanded that to proportional hazards and other models. Hannah has worked on this, and it's in the censored package. What we did was add a proportional hazards model function, and you'll see that in a minute. We have sort of like a new modeling mode. So what we do is we have modes for like classification, regression. I'll show you a new one here that's for censored regression, which means we estimate performance and do some things differently for this type of model. And then we've added new computational engines for parametric models, tree-based models, and so on. We've also decided to sort of standardize on the survival packages formula interface. So there are some models that had a sort of a weird or non-formula interface to their code, and we've sort of standardized everything to work on, like, you know, Surv objects and strata and things like that you would see in the survival package. So the data set I'm going to use, I didn't want to use a medical data set because honestly, there's a number of them, but they're very small and we've reused them over and over again. So I have some data that is timed to $1 million of revenue for movies. So each row here is a different movie. We have features that are, you know, how many theaters are released in, who released it. We have genre keywords and things like that. And we want to make predictions and model these data. One thing that we want to do up front, which we'd like people to start doing, is when I look at survival code, usually I see people constantly making their Surv objects. What we'd like people to do is to do that up front and make just a column in your data set for that object instead of keep remaking it. A little known thing in Mutate here is you can add this option that will drop time and event from your data frame, since it's all embedded into this object. And for this particular data set, there's some ID fields that we'll get rid of and then do our modeling on these. So in tidymodels, if you've never seen it, it's set up where you set up the structure of the model that you want to fit, and then you decide how to fit it. And so, for example, proportional hazards has a very particular type of, semi-parametric equation, but there's a lot of different ways to fit that model. So what we're going to do is fit a regularized Cox model here. So we start off with the model specification, and you can list any parameters like main arguments to those functions that you want to use. So we'll use L2 penalty here, and we'll use the glimnet as the engine. So basically, this is the structure of the model we want to fit, and this is basically how we want to fit it. And so at this point, we've specified what we want to do, and then you can just use the fit function to do that. And here you see that, again, we standardized on the regular formula interface. In tidymodels, we have some nice little convenience functions, like the tidy function. Many of you have probably seen it from the Broom package. So there you can get the whole regularization path of your model. We've also added a nice autoplot method, which gives you, the parameters across penalties. There's an optional argument here that you can specify a particular penalty and tell it how many of the largest parameters you'd like to feature or show off here. And so that's what we have there. As you'll see in a little bit, the nice thing about tidymodels is it's relatively standard in a lot of things. So if you want to list your penalty here, you can do that. If you want to optimize it, the code is pretty much the same. If you want to switch models, code is very, very similar. So that's the nice, some of these niceties for using tidymodels with this type of data. In terms of the models that we have right now, I think maybe Hannah added 2 this week, but I wasn't sure, so I didn't list them here. But we have more engines for proportional hazards. We have a variety of different tree-based methods, parametric models, and so on. We want to keep adding here. So if there's particular things that you're interested in, make a GitHub issue or tweet at us or whatever you want to do. We definitely want to get as much feedback on this as we can. We'll focus on predictions for a minute. I know a lot of times with survival models, we're interested in inference, but let's look at how we would make predictions, even for illustration. So for most models, if not all of them, we have prediction methods of time and survival. So time would be the estimated survival time or event time. Survival is the survival probability. We have some other engine or prediction types. Like linear pred would be something you can get for linear models or linear-ish models, but you couldn't get for trees, and so on. We also have this sort of like way we do things in tidy models where we've standardized on predictions. A lot of these models will give you very different objects back that you have to mess with to use them in a standardized way. So we always give you a tibble back. The column names are very standardized. And if you come in with, n data points into predict, you get n rows out from predict. And so that's not always the case with some models, and we want to fix that. So let's take 3 movies. I'll unblind these in a few minutes. When we get probability predictions, we'll make predictions at weeks 1 through 50, a sequence there. And if you just want to get the simple event time predictions, type equal time, and then you can see one movie really quickly had revenue come up, and then another was very slow, and one was in the middle. For survival probabilities, you just change type equal survival and tell it what time you want to make the prediction at. And what you get back is a nested series of tibbles. So again, if you come in with 3 different rows, you come out with 3 different rows. The data structure here is a little bit more complicated, so we sort of embed that in a tibble. Each one of these tibbles has, as you can see below, the time you're making the prediction at and the survival probability. It looks intimidating, but you can very easily just unnest it using tidyr, and then you get a stacked data frame. You can take that data frame and just put it in ggplot. And so here's some code to do that. The really fast movie was Ant-Man, and I kind of like the Sorry to Bother You movie, and its revenue was much more slower to hit, if it ever did, a million. So yeah. So what's next that we want to do with censored? We're implementing performance metrics, so things like time-dependent RC curves, Bragg curves, and so on. If you have your favorite performance metric for survival analysis, please let us know. And also tighter integration with tidy models in general. So whether it's performance metrics or things like resampling or model tuning, those should be coming along shortly. And again, we want to hear from you if there's something you'd like to see or something we're missing. So next up is H2O integration. This is new to tidy models. This is work done by Shushi during his summer internship. Also, this is in conjunction with Tomaz at H2O and Aaron Liddell at H2O. H2O integration is something we wanted to do for quite a long time and finally got around to it this summer. If you've never heard of H2O, it's sort of a server-side modeling framework that uses Java under the hood. There are APIs in Python and R, and we wanted to be able to use H2O models just like you would anything else. The nice thing about H2O is it's really fast and can handle large data sets. You can have this H2O over running locally on your computer, which is what I'm going to do. Or if you have like a big HPC cluster, you can put it there. And this could make you capable, this allows you to fit many different models very quickly. So it's a nice functionality to have. So the main thing you'll do, as you'll see in a minute, is specify a computational engine of H2O. We have this for a variety of models. They have like survival models. They have like logistic regression, deep learning, neural or trees, and so on. The important thing that we thought about when we were developing this is to make sure we minimize the data handoff between R and H2O. What we didn't want to do is, as we resample or tune models, just send stuff back and forth constantly, and that saves us a lot of time. There's also some standard H2O functions that we sort of made wrappers around because we thought it would be a little bit easier to work with. For example, some of the functions are very verbose, and we shy away from that as a default. So this code is in the Agua package. So if you want to use it with tidy models, you load tidy models meta package, and then you can load this. Here's some data I won't go into too much. It's basically clinical biomarker data for dementia in patients. We'll split the data into a training and test set. That's what this does. And then start an H2O server, or if we have one running, specify which one we want to point to, and then fit basically a logistic regression using H2O. And then, that's what we specify here. And then we just fit the model like we would usually. And then if we print that out, there's a lot of output that comes out of H2O, but, it's here. The main thing to realize is really these are the only 2 pieces that are different. So with these 2 modifications to code, one of which is pretty basic by sending the engine, we're actually get access to a really, really efficient, potentially external computational engine. Once we do that, like our fit works like anything else in tidymodels. We can get predictions on it. We could pull out the actual H2O model and use that directly. So if we use the VIP package, we can run the VIP function on that model and get our plot of variable importance scores. So if there's plot methods or print methods or whatever we want to look at, we can pull those out just like we would in R object. We can also do hyperparameter tuning. So let's say we want to fit a regularized model like we did with GlimNet. We can specify the L2 penalty or the penalty in general, and we can tune over whether it's L1 or L2. And in tidymodels, instead of giving it a value, you would assign it a value of tune, which is just like a little tag that says you should optimize this. We do some pre-processing for our model, and then we can then just run it through tune grid, which will basically do resampling across a grid of penalty values, which will let the machine figure out those values and get our results back. And again, the important thing to note here is this is really the only thing that's different from just using an R package directly to do the computations. Parallel processing is pretty easy to do here. The thing that we had to look at is H2O does parallel processing on their server. R does parallel processing. Should you choose one or the other? The vignette that's linked here, there's links to the slides at the end. We basically figured out that H2O is good at processing multiple models at once, but if you also use it in conjunction with R's parallel processing, you can throw like a ton of models at the H2O server and it knows how to queue them and set them up, and it's very efficient. So we think that if you want to get pure efficiency out of these, you can use both parallel processing in R and H2O's methodologies to get like really fast model fits. H2O is known for its AutoML code, which is basically stacking. That's something that Aaron's written and researched and did a lot of work on. So we added a new AutoML type to parsnip that basically runs with H2O right now. So you can declare that model. This is an optional thing that I just did here, which is, how long should I let this thing run before it tries to fit an ensemble? And this makes H2O run out or start running a bunch of models that models that they believe are the best substrate to go into stacking. So you've given it, let's say, 5 minutes, and it goes out and does as much as it can. And then as it goes, it starts to ensemble them and see what works best for them. So that all happens when you use the fit function on this model object. And then as that goes, you can query the leaderboard. And in this particular case, I don't know if you can read it, but its best model is a stacked ensemble. And the second best is just not a simple deep learning model, but a single deep learning model, which had about the same performance. So this will help you understand like whether you should maybe use an ensemble or use an individual model and make those trade-offs. There's a lot of work that Xuxi did on this to work with AutoML inside of R, and it's really nice. There's a good vignette on it. For example, there's some autoplot methods where you can look at how much each model contributes to the ensemble, or if you want to check out the leaderboard and make comparisons and things like that. It's pretty smooth. So if you're interested in this, give it a try. It's really good work. And that's number 2. Number 3 that we have is clustering. And this is done by Emil, who's in the tidymodels group. It's not on CRAN yet, so it should be very soon. We're sending out a flurry of little package updates to get everything ready for the tidyclust package. And it allows you to basically specify what type of clustering model you want to try, do the estimation part of it. You can make predictions, like if you have a new sample, you can figure out what cluster it should belong to based on your model. And then there's other things we can do to evaluate the clustering model that we have using some quantitative methods. Again, if you've already used tidymodels, you'll see that the syntax here is very different, or I'm sorry, very, very similar, to what we have for supervised models. So we haven't really done much with unsupervised techniques. We have some models or some packages for applicability domains, which I've talked about at this conference before. But tidyclust is something that Kelly Bodwin, a collaborator, suggested to us. And then I think we sort of drove the development of that. So Kelly is really important in getting this working. So if you want to use it right now, you can install it from GitHub. It's in Emil's repo. Once it's on CRAN, this will move to tidymodels. This code will still redirect you to where it's supposed to install. So you can just use this if you have it. And then if you load the tidyclust package, you have access to everything you want. It sets up a model type or a clustering type called k-means, which does k-means clustering. You would specify the number of clusters. And just like with supervised models and engine, so there's different ways you can actually do the computations with k-means. And then we have a new mode, which is partition, which is unsupervised clustering. And again, this is just a specification of what you want to do. If you want to fit it, what I'll do is I'll take our biomarker data, get rid of the other non-quantitative predictors in the model, and then do some normalization and pre-processing on those. So this recipe sets up how we want to process our data before we give it to the clustering tool. And then in tidymodels, we have this thing called a workflow. And a workflow is when you combine a preprocessor, which could be a recipe or a formula and so on, with a modeling method. And if you do that, then you have a really simple interface of doing fitting and prediction. So by using fit here on the combination of the recipe and the clustering object, it basically does all that at once and does the fitting. And then when you print it out here, you can see this is the output you would get back from the k-means function. You may not know how many clusters to use. And so one thing you can do is you can optimize that just like you would anything else in tidymodels. So as I showed you before, when you want to optimize something, you just give it a tag of tune, and then tidymodels knows something about that parameter. It knows its range and what type it is. You can give it a tuning grid if you want, or as I did before, you can just give the grid argument a number of how many you should try. One nice thing that's not illustrated here is if you have some sort of really fancy pre-processing tool that might need optimization itself. So in your recipe, you can go and tune any things or tag any things in that recipe that you want to optimize with that tune tag. And then using this, you could jointly optimize the pre-processing as well as the clustering of your data. So, so tune cluster is sort of analogous to tune grid. All the syntax is the same, but it's for unsupervised clustering. And then when you collect your metrics from there, you can see how performance changes as the number of clusters goes up. We may not want to look at a big grid of numbers, so there's an autoplot method. In this case, we're going to show the total within sums of squares. And it suggests maybe you should use more than 20, but you can also go back and use other metrics or just look at your eyeball, use your eyeballs to say, oh yeah, it looks like, to get that down, we're just looking at splitting hairs. But this would help you get some guidance on how complex your clustering should be. So those are the three things. Thank our collaborators again, our external collaborators, as well as the RLib, tidymodels, and tidyverse teams at Posit PVC, not our studio. That's official this month. If you want the slides, they're on my GitHub repo 2022-r-pharma. And if you don't know much about tidymodels, take a look at the tidymodels book, which you can read here or buy from O'Reilly. Tidymodels.org has a lot of articles and tutorials and getting started materials. So that's another place you can get information. And thanks.
Thanks so much, Max. That was fantastic. Emil put the link in the chat too. We got over 300 people clapping, so thanks again, Max.
Thank you.
I have one question. Any updates, packages? This is from Anonymous. So it says it's kind of so any updates, packages coming soon for measuring biases and model predictions?
Measuring biases and what?
Model predictions.
If we're talking about like bias in terms of fairness, we actually have a reading group going as a company where we're just reviewing all the techniques and methodologies for like model fairness and parity and things like that. If that's what we're talking about, it's a big field and there's a lot that we could do. And so we're probably going to start. I mean, I have some code from previous stuff, but we're deciding what we should do now and making sure that we can give you functions to do that, either post hoc after your model is done fitting or tuning, as well as maybe before you start the process. So that's definitely something that it's on our goals. It's on our user survey. So yes, I can't tell you really when that's going to happen, but there's that. We're also currently working on classification, calibration. So there's bias issues there too. So if you have thoughts about that, let us know, or either of those topics. Yeah.
Okay. Thank you so much, Max. Again, this is fantastic. And the tooling and the education that tidymodels continues to pioneer, fantastic. So thank you again.